Alright guys, here's a little walkthrough of how to do the application homework problems. Okay, so taking a look at this first one, it says Abby can paint a house in 5 hours, Spencer can paint the same house in 7 hours. How long would it take them if they both painted it together? Okay, so if we're taking a look at this, we're talking about a job, okay, and we're talking about a specific number of hours we can get that job done in. So this is considered our work or our job problems. And so the equation for that is you take the job and you divide it by the number of hours that person can get it done, and then you multiply it by X hours. That X specifically is the time that we're looking for. So then this would be one person. We can call this one Abby. And we also want to know if they work together. So I'm adding them because they're working together. Then we would have another job divided by hours multiplied by hours. That would give us out job, right? And then we can consider this Spencer. So then we need to just fill in everything that we know. So we know that Abby can get one job done in 5 hours. Multiply that by X. We know Spencer can get the same job done in 7 hours. Multiply that one by X. And then what do we want them? They want to do that one job together. So then the job at the end should just be one total job. So then the easiest way to do this question, guys, would be to find a least common denominator and get rid of all the fractions. So least common denominator between 5 and 7 would be 35. So then we take the first one, we multiply it by 35, the second term we multiply it by 35, and the last term we multiply it by 35. 35 divided by 5, those cancel and give us 7. 35 divided by 7 gives us 5, so we have 7x plus 5x is equal to 35. 7 plus 5, that's going to give us 12, so 12x is equal to 35. So then we divide by 12 on both sides, and we would get x is equal to 35 twelfths. Okay, you could also put 35 divided by 12 into your calculator and get 2.917 hours. So approximately 2.917 hours. Okay. If you wanted to get fancy, you could take 0.917 and multiply that by 60. That would give us the minutes. So that's going to be 55 minutes. So then you could say it took them 2 hours and 55 minutes to complete painting the house if they worked together. Okay, but by all means, decimal is a great answer, fraction is a great answer, as long as you're putting the units on there, guys. Alright, so now let's say that Abby woke up extra early and started painting the house an hour before Spencer got there. How long will Abby be working and how long will Spencer be working? So this time, the amount of hours is changing between Abby and Spencer, right? So it's saying one job in 5 hours, that would be Abby. One job in 7 hours, that would be Spencer. Spencer is working the normal amount of time, so we would just multiply that by X. Abby is working the normal amount of time, but she also added 1 more hour to her work, so we would put X plus 1 because she's working an extra hour. We add those two things together, they're still trying to get one job done. Okay. So, from here we have lots of options. We can find our least common denominator and multiply through. We could distribute 1/5. Okay, there's really many things that you could do here. But what I'm going to do, I'm going to find the least common denominator, and I'm going to multiply everything by that, so 35 again. So then we have 7x plus 1 plus 5x is equal to 35. So then if we're continuing that, distribute the 7, we would get 7x plus 7 plus 5x is equal to 35. So we could subtract the 7 to the other side. So that's 12x is equal to 35 minus 7, which would be 18. divided by 12 on each side. X is going to give us 18 divided by 12, 1.5. Okay, so that's 1.5 hours, or you could say that that is, what is that? 1 hour and 30 minutes. Okay, you would definitely want to simplify this if you're leaving it as the fraction though. So simplify that would be 9 over, oh actually 3 comes out of both of those things, doesn't it? Oh, bigger, 6, 3 over 2. Alright, number 2. So it says thing 1 can mow the lawn in 2 hours, thing 2 can mow the same lawn in 90 minutes. Right? If they had 2 lawnmowers, how long would it take them to mow the lawn together? So mow the lawn in 2 hours, so 1 over 2 hours. Thing 2 can mow the same lawn in 90 minutes. So that one, 90 minutes, we need to convert to hours. So to convert that to hours, we could take 90, and then we divide it by 60. 90 divided by 60. What is that? 1.5. Okay, so that's 1.5 hours. If they had 2 lawnmowers, how long would it take them to mow the lawn together, right? So thing 2 can mow the same lawn in 90 minutes, which is 1.5. So then I would actually change that to its fraction form, right? So 3/2, so it might have just been faster to reduce 90 over 60. So then what we have, we'd have thing 2 can do 1 job in 3/2 of an hour, okay? We're trying to see how long it would take them to finish 1 job by itself, or together. So then we take a look at this 3/2. Okay, this is a fraction divided by a fraction. So to simplify that, right, we just flip the bottom. So it becomes 1 multiplied by 2/3. X equals 1. Okay, because if you take 1 and you divide it by 3/2, that would be the same thing as taking 1 and multiplying it by 2/3. So then we have, now we can find our least common denominator, right? 2 and 3 would give us 6, so multiply everything by 6. That gives us 3x plus, that's going to be 2 times 2, which is 4x equals 6. So that's 7x equals 6. So divide both sides, we would get x is equal to 6/7, which is 0.857, and so on and so forth. And then that would be in hours, right? Because it says we use the units hours, okay? By all means, you could convert 2 hours into minutes and then get a minute answer here. But again, that's all up to your preference of how you decide to go about that question. All right, next one. Logan and Drew got hired to work at UPS. Logan can move an entire stock of boxes from one platform to another in 4.5 hours. Drew can move the same number of boxes in 3.5 hours. If they work together, how long will it take them to move the boxes? So again here, guys, I would convert these into their fractional form. So 4 would be 8 over 2, so then 9 over 2 would be 4/2. 3 would be 6 over 2, right? So then another half would be 7 over 2, right? If you're a little confused on how I'm doing that, guys, 8 over 2 is 4, plus 1 more half would give us 9 over 2, right? If they work together, how long will it take them to move the boxes? So then we have Logan, who can do it in one job in 9.5 hours, or not 4.5 hours. Multiply that by x. Plus Drew, who can do that same job in 7 over 2 hours. Multiply that by x. We want to see how long it will take them to get 1 job done if they work together. So then from here, simplify this. So 2/9 x plus 2/7 x is equal to 1. Least common denominator between those two things would just be multiplying them together, so 63. So then we take everything and we multiply it by 63, multiply by 63, multiply by 63. So 63 and 9 would cancel to make 7, so that would be 14x. 63 and 7 make 9, so that would be plus 18x equals 63. Okay, and then 14 plus 18, that's 20. 32x is equal to 63. Divide by 32 from both sides. 63 divided by 32 gives us x would be 1.969, and then the units is hours again. Alright, next one. Taking a look at what if Logan starts 20 minutes before Drew? So 20 minutes, so 20 divided by 60, let's get that into hours, would be, what is that, 2/6? I'm going to leave that as a fraction for now. That seems more helpful to me than a decimal, so let's leave that as 2/6. So then Logan is the person who can get it done in 9/2 hours. So 1/9/2 multiplied by x plus 2/6, because he started early. And then Drew would stay normal, so 1/7/2 x. Okay, and then let's do some simplifying to this equation here. Slide it up here. So it's going to be 2/9 x plus 2/6 plus 2/7 x, and then that's equal to 1. Sorry, I forgot to put the equals 1 right here. Alright, coming through this again. Okay, there's a fraction here, fraction here, fraction here. So it looks like what I want to do, I'm going to just find the least common denominator right now between 9 and 7 again, so that's 63. So let's multiply everything by 63. That would give us 14 times x plus 2/6 plus, and then that's going to be 18x is equal to 63. Alright, and then let's distribute this 14 in. So 14x plus, we'll go 28/6 plus 18x is equal to 63. We can reduce this down. 28/6 is going to reduce, what is that, both divisible by 2, so 14/3. Alright, so now that we have 14/3, we can, I guess we could get rid of that fraction, or we could subtract off 14/3, it's your call. 14/3, so that's going to give us a different color here. That's going to give us 32x is equal to 63 minus 14/3. Okay, and then from here, 63 times 3, 189. So 32x equals 189/3 minus 14/3. So 32x is equal to 175/3. So we can divide that by 32, and that would give us our decimal. So x is equal to 175 divided by 3 divided by 32 gives us 1.823 hours. Okay, so it got done a little bit faster, right? But only a little bit. That's only because Drew started 20 minutes before him. So let's see, or Logan started 20 minutes before Drew. So let's see if we increase the amount of time it would take for them to do this question, right? See if it goes any faster if we started even earlier. So now we're going to have Drew start 45 minutes before that. All right, so then we can do the same thing. Let's take 45 minutes and make it into a fraction. So 45/60. What does that reduce to? 45 divided by 5. So 9/12, which reduces more. 3 comes out of both of those, so 3/4. All right, so if we're taking a look at this, 3/4, what I would do again, right, let's set it up. So by this point, hopefully we know that this is the equation. It's 2/9, and then now it's just going to be x for Logan plus 2/7 and now it's going to be x plus 3/4 because Drew started earlier, and then that's equal to 1. Okay, and then let's take everything and multiply it by 63. Use a different color so we can see it better. Multiplied by 63, multiplied by 63, multiplied by 63. Okay, and that's going to give us 14x plus 9x, or 18, sorry, 18x plus 3/4 equals 63. So then we're going to come through here. We get 14x plus 18x plus 18 times 3 divided by 4 is 13/5, so that's going to be 13.5. 18x plus 54/4, I think was what I got. Wait, no, what am I doing? 18 times 3. Yeah, 54/4. Yeah, 13.5. So that equals 63. 32x plus 13.5 equals 63 minus the 13.5 from both sides. 32x is equal to 49.5 divided by 32. And then we get x is equal to 1.547 hours. All right. And then that's how you would do that one. Okay, one last one to go. Let's see if we can get this last one. So Ian is qualified for the 2012 Olympics. His specialty event is the 1600 meter race, and he has a flawless strategy. For the first 1200 meters, he runs at 1 pace, and then for the last 400 meters, he runs at 1 meter per second faster than he has before. If his final time is 3 minutes exactly, how fast is he running during his last leg? So this is going to be our rate question, right? It tells us that 1600 meters is the total distance, 1200 meters at 1 pace, 400 meters at 1 meter per second faster. He wants to finish at 3 minutes exactly. How fast is he going to have to run? So the question here then is 1200 meters. He's running at x at a constant speed, right? We would add that to 400 meters. He's running at x plus 1. So x is considered his constant speed, but then he goes 1 meter per second faster, right? This comes from distance over rate plus distance over rate would be equal to time. That's the equation we're working with here. The total time that we want is 3 minutes, okay? Notice though that this is in meters per second. Okay, so then let's make this minutes into seconds. So that's 3 times 60 would give us 180 seconds. So then 180 here. Okay, and that's how you would set up this question. The distance divided by the rate plus the distance divided by the rate is equal to the time. All right, now that we have that all set up, what we can do is we need to figure out what is the least common denominator. Make it a different color. Least common denominator in this case would be x times x plus 1, because those are the things in the denominator. None of them double repeat or anything, so it's just those two things. And then we multiply all of the terms by that. So then x's cancel. We get 1200x plus 1200. And then plus the x plus 1's cancel, so 400x. And then that's equal to 180x squared plus 180x, right? So as soon as we distribute all of those things, that's what we would get. And then from here, it's just a lot of simplifying, right, guys? So we're going to do 1200 plus 400 gives us 1600x plus 1,200 is equal to 180x squared plus 180x. Because this is a quadratic, guys, we have to get all of the terms to one side. So now we're going, what I would do is I would subtract off the 1600x and the 1200 here. As soon as you do that, that zeroes out the left side. We have 180x squared. 1600 minus 180 was negative 1420. X minus 1200. Okay. And then 20 definitely comes out of all of these things, so we divide all of these by 20, which would be more helpful for us when we need to either factor or use the quadratic formula. So that zeroes that out, and it gives us 9x squared minus 71x minus 60. All right. And then I don't think that this one is going to factor nicely for us, so let's just go right into the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplify this out, it'd be 71 plus or minus the square root of 5,041 plus 2,160, I believe, divided by 18. So then we have, this would be equal to 71, and then plus or minus 84.86 over 18. And then, honestly, guys, if we did minus, it would give us a negative solution. So we don't really care about the negative solution. Speed is always a positive thing. So then if we did 71 plus 84.86 over 18, we would get 8.66 meters per second. Okay, and this is his constant speed, but during what part of the race? This is the constant speed. If we look back, this is the constant speed during the 1,200 meter section of the race. It wants us to know how fast is he running in the last leg. So that last leg, he moves 1 meter per second faster than this. So it would be 9.66 meters per second would be your final answer. Okay? And by all means, guys, there's other ways to do this question, right? You could have also started this question with a completely different equation, still got the same answer. Instead, you could have done this. You could have said x minus 1 here. And then you could have just called this first part just x, and then your final x value would have been this 9.66 right here, right? But again, it's all up to preference on how you see the question. Okay, and that's how you do all of these different questions.